Hello friends. In the fourth standard, we have seen comparison of like fractions. What do you mean by like fractions? The fractions whose denominators are equal means both of the wholes, they are divided into equal number of parts. In that case, the number of parts we have taken or considered can be compared very easily. We're going to take an example of a disk. This is being actually divided into 12 equal parts. You can see that some part is shaded with the red, some part is with yellow, and some part is in the white. Now, what is the fraction of the red part of the circle? You can see that 7 parts out of 12 parts they are shaded with the red. So fraction is 7 out of 12. Now, what is the fraction of yellow? You can see that fraction of yellow, 2 parts are there. So definitely 2 parts out of 12 parts. So 2 by 12 is a fraction of yellow. What is the fraction of white? You can see that there are 3 parts in the white color, and the fraction of white is 3 by 12. Now, which fraction out of these 3, whether red, yellow, or white, is the greatest one? Definitely, you can see that the red color is more in the more parts. So 7 out of 12 is the greatest fraction in all these 3 fractions. While on the second number, it comes 3 part out of 12 parts for the white. And on the third, it comes 2 part out of 12 for the yellow portion of the circle. So why these are very easy, relatively easy to compare? Because the whole is being divided into equal number of parts. If I am going to take an example of a circular disc, another circular disc, this is being divided into 8 equal parts. And if I say to compare the fraction of blue with the fraction of red on this disc, then it will be difficult to compare because the number of parts in both the discs, they are not same. Number of parts made in the disc, they are not same. So they are unlike fractions. What is the fraction of blue in this case? It will be 3 out of 8, and the fraction of red is 7 out of 12. And now they become unlike fractions, and it is difficult to compare unlike fractions. So how to compare unlike fractions? So first of all, we'll see some more examples related with the comparison of like fractions, and then we'll go for comparison of unlike fractions. For that, I'm going to share my presentation. So we'll start with comparison of unlike fractions. First of all, with the like fractions, and we'll see some examples of like fractions. So what we are going to do, we are going to take 2 circles. First circle is being divided into 8 equal parts, and 2 parts are shaded with the red. Second circle, again of the same size, is divided into 8 equal parts, and 3 parts are shaded with the green. So which circle is shaded more, or which fraction is greater? Definitely you'll see that green part or green portion of the circle is greater, so the fraction 3 by 8 is greater. Also, the number of parts are 3 in the second case and 2 in the first case. We'll take an example of 2 rectangles. First rectangle and second rectangle, both they are having the same size. They are both divided into 10 equal parts. First rectangle, 4 parts are shaded with the blue. Second rectangle, you can see that green part, there are 6 green parts in the second rectangle. So the fraction of the first color, that is blue color, is 4 by 10, and that of a green is 6 by 10. Which fraction is greater? Definitely by looking at the figure, you can see that 6 by 10 is greater than 4 by 10. In both the cases, you can see that the denominator is equal, and it's very easy to compare the like fractions. One more example I'm going to take of chocolate. You like this very well. This actually having 12 equal part in one chocolate. I'm taking 5 part over 12 part. So fraction become 5 by 12. Second chocolate I'm taking, and I'm taking 7 part out of it, and the fraction will become 7 out of 12. So the first fraction is 5 by 12, and second fraction is 7 by 12. Now, which part of the chocolate is more or is greater? That is definitely 7 by 12 is greater than 5 by 12. So it's very easy to compare like fractions because we just going to compare the numerators, and the denominator is same. Now, what to do about unlike fractions, how to compare unlike fractions, we'll see in the next video. Till then, goodbye.